This is an interesting project. It's to make LED illuminated signage by printing off custom housings that you can put LEDs into, and then front plates that can then simply be clipped into the front to give it the desired colour. And this project started out when I was thinking there must be signage modules available on something like Thingiverse. And I went and looked in Thingiverse, and there were some signs, some projects that people have made with just a word, but nothing customizable. So I set about making an openscad script, and it turned out to be complex but doable. It ended up really, really short because I discovered the Minkowski command, which lets you fatten things up and shrink them down, and that's pretty much what I'm doing here. So I'll show you what I've done here, and then I'll describe the script, which is actually down in the description down below, and show you how to change the settings to get different effects. So in the case of this green character here, let's pop this cover off. I shall use the spudger for this. It's probably a good idea. The front faces are a fairly close fit, but they go in fairly easily. Inside is LED tape just run around the outside. The effect of that is this only works in the light coloured boxes. It bounces the light around inside to create that light box, but notice that the front cover of this is actually slightly transparent, and it means you can actually see the LEDs through it, which is an interesting effect, but perhaps not as diffused as something like this. In the case of the X, I shall spudger this out. It's just a crisscross of LED tape in the back of that, and it is a light coloured case. It's a Wood Effects, a PLA, and it provides a bit of diffusion and bounces the light about to spread it and make it look quite, well, even and diffused. The red one took the approach of LED tape around the outside again. I've noticed that the LED tape does not stick very well onto this plastic. This might just be the use of crappy LED tape. I also kind of regretted I just did an outline of this one doubling up here, but I should really have actually doubled up in here and gone around here as well for extra brightness, because as it is, the amount of LED tape is small, so it doesn't draw much power. Each letter only draws about 1 watt, so it's pretty low power. By increasing that a small amount, I would have actually got a better illumination and evenness, but this is prototype stuff. One last illuminated letter here, one of the first I did, and it is just sections of the LED tape on the back coming unstuck as it does. I'm going to have to brighten this up, haven't I? Yes, I am. I'm going to have to brighten up now. That's better. But it's sections just bridged together with short bits of wire just tucked out the way of light, and they bridge at the top. They're actually using the pads along the LED tape to just jump across from one bit to the other. So this script allows you to produce characters like this. It lets you use Comic Sans if you want. A.R. Berkeley, and this is Arial. And this I think is Arial Black. It's a really thick, bold font. But you can actually use any font that the OpenSCAD will actually support, and all the symbols associated with it. Right, tell you what, I'm going to clear all this stuff away, and we'll take a look at the script. A couple more exhibits here actually, just to show you that, you know, nice friction fit of these things, these front plates, even in quite complex shapes. Right, okay, I'm going to pause, clear this away, and we'll take a look at the script. One moment, please. Let's take a look at the script. Well, the top of the script where all the variables are, because that's the bit that you'll be changing to get your custom results. I've printed it off like this so I can show you what the effect is on a physical object. So the first variable is letter, equal A in this case. If you ran the script with that, it would actually print an A, like this. You can change that letter to any upper or lowercase letter, or even symbols like plus, minus, asterisks, ampersands, and at symbols. Anything you want in the font can be printed. Note that it has to be in the quote marks and have the semicolon after it. Those things are important to leave in for the program, because that is part of the program. The next variable is style, which in this case is Arial. It's the font, and I think this is an Arial, and this one is A.R. Berkeley, I think. Quite nice actually, quite a stylish font. If you go into OpenSCAD and you click Help at the top of the screen and then Font List in the drop-down menu. It will show you a list of the fonts that are available. Note that they have to be typed in as they're listed in that with correct capitalization. So if it's all in capital letters, you have to type it in capital letters and vice versa. If it's all lowercase or just capitalized at the start, just make sure that you type the font. And I've noticed that not all fonts necessarily are implemented in the system. If the font you choose isn't implemented, you'll end with a basic font like this, just a standard one. Size equal 50. That is the height of the character. In fact, this A.R. Berkeley thing is about 50 millimeters, which is about 2 inches tall. In this case, this one's about 120 millimeters tall, I think. The next variable is depth, which is the depth of the chamber that you're going to be putting your LEDs in, or just if you want to leave it empty and have a nice boxy character. The next option is $FN, which is, it's not a nice way to present it, it's part of the program. Leave it at 100. Typically that indicates the facets around the curve. Say for instance, if it's 360 degree circle, it will be about 3.6 degrees per facet. That just gives if you make it too low, it's very sort of flat and sort of ribbed feeling. But if you increase that, say up to 360, it would be much smoother. But in this instance, 100 is fine, and making it too big makes it slow. It takes a lot longer to render the image because it's calculating more curves. The next variable is walls, which is 2 millimeters in this instance. That is the thickness of the wall. For a character this size, 2 millimeters is ideal. If you were going up to a character 300 millimeter or a foot tall, maybe you'd want to go for 3 millimeters. That also determines the size of the ledge that is used to support the front face, because it will be half the depth of the wall. So in this case, it's a 2 millimeter wall. It will have a 1 millimeter groove going into it. The next option is base. That's the thickness of the base. You can make it -1 and it will just be transparent right through, but you will have separate pieces here that can still be clicked and glued into the face, but the back will be completely empty. That's handy if you want to have some LEDs in the front of it, shining out the back. I found it very useful when printing the test figures to adjust the base to 0.4, because that's the equivalent of 2 layers of plastic with a 0.2 millimeter nozzle, and it just means that it prints very, very quickly, because that takes a lot of time, the printing the back surface. The final variable is face, and that is the face thickness. I've chosen 1 millimeter for these ones. The thickness you choose will depend on the size of the character and how translucent you want the plastic, because if it's too thick, it will become perhaps a bit too opaque and block the light. But it's entirely what you want to do. Let's take a look at the other script. And again, there's information about these down below in the description, along with the scripts. This has all the same variables and they have to match. If you make a letter like this, everything has to match in size, including the choice of letter, the font, the height, the curvature, the wall thickness, because it's going to determine this size of this letter for fitting into the lip, and of course the face thickness itself. If you make the face thickness thicker, if you say for instance you told the body it was going to be 1 millimeter thick, but you in the face bit you actually said the face script, you said it was going to be 2 millimeter thick, it would still work, but it would just stick up by 1 millimeter. That in its own right could be quite nice. There is one extra variable called fit. What fit does is it just shrinks the character in a little bit, so that when you've got the face, to make sure it is going to come off the print bed with a slight squish around the bottom, it compensates that. It just shrinks it in so that literally you can take the face off the print bed. I'm just going to pop this off right now. It's going so snugly. You can literally just take it off the print bed and just place it in, and it will just click into place nicely. It's very good. It worked out really well. But that is it. The script's down there. Play with it to your heart's content. I'd recommend starting with small characters like 2-inch high by 10mm deep, as the script is already set up for, and just play about with it. Notice that, note should I say, that there are no holes in the back for putting screws through, because there are so many characters it would be impossible to actually just have fixed places you could put screw holes in the 3D printer. So you'll have to drill those to your own requirements. Also the hole for the cable inlet for your lighting, but that kind of varies anyway according to what sort of lighting you use and where the best connection point comes. But that's it. Help yourself to that script down below. Load it into openscad and play. It's the best way to actually find out how it all works. And let me know how you got on. Let me know if you enjoyed using it, and definitely experiment with all the different fonts. It's quite a fun project.